Bismillahirrahmanirrahim. Assalamualaikum and very good day to you all. In this video, I'm going to talk about the chapter stress, okay, which is the chapter 3.4 in Shikli Mechanical Engineering Design textbook. It is from the chapter 3, uh, load and stress analysis, okay. This is a chapter I'm going to talk about the stress, okay. Introduction to stress. What is a stress? Stress is an internal force per unit area within a material. It determines how material react to external forces. Okay, type of stress. Normal stress acts perpendicular to the surface, where shear stress acts parallel to the surface. Unit of measurement is measured in SI unit as a Pascal and pound per square inch in US unit. Okay, 1 Pascal equals to 1 Newton per meter square. For example, a steel bar with force of 10,000 Newton flight over 0.01 meter square experience 1 megapascal of stress. Because you would divide it using the formula, you can get this value 1 megapascal of stress. Okay, so there are tensile stress, and there are compressive stress, and there are shear stress, and there are normal stress. Okay, definition of normal stress, which is normal stress occurs when force applied perpendicular to the surface. Like for example, you uh you you put your hand on your table and you press your hand onto the table. Okay, the force is perpendicular. That is called normal stress. Okay, normal stress. Formula for normal stress is sigma equals to force over A, where F is the applied force and A is the cross-sectional area. Okay, tensile stress is called elongation. Okay, that is when you use the machine, universal testing machine. I'm sure every engineering school have this machine, universal testing machine. They want to test the elongation, and this is called the tensile stress. And then the same machine can also test for compressive. Okay, compressive stress. Okay, a beam in building undergoes compressive stress due to structures weight pushing down onto it. Okay, and then there are shear stress, which I have make a video. In the previous video there are a lecture on shear stress. Shear stress acts parallel to the surface caused by force attempting to slide one layer of material over another. Formula of shear stress is tau. Okay, the symbol tau equals to shear force over area, where shear force is the shear force and A is the area. Key role is shear stress is a critical in component like balls and rivet that must resist sliding force. Okay, we don't want them to become uh, fractured. Okay, because the ball and the rivet must be strong enough to resist sliding force. There is scissors that you have used it in your kitchen or in your school. Scissors apply shear force to a piece of paper, create parallel stress along the cut surface. Okay, practical application of stress. Understanding stress is vital for designing a material that can safely bear the specific load, such as bridges and airplanes. Engineers analyze stress to ensure structures last and remain safer under various force. High tensile strength like steel and high compressive strength like concrete are chosen based on application. For example, Golden Gate Bridge cables on endure tensile stress to support the weight of the bridge, while the pillar bears compressive strength. Okay, compressive stress. Okay, that's all for the video right now. Inshallah, we meet in the next video. Thank you very much.